Okay, so this going to be our second topic assessment audit. And I hope you understand the first one we talk about. Now today we are learning about risk and return. We talk about risk and we learn about how to calculate and determine the risk of a single investment. So I've said that we are surrounded by risk. And our investment, for every investment you make, there's a possibility of you losing your investment or even losing the returns that you are expecting to get on it. Now, we then ask, what is risk? What is risk? When we talk of risk, we are basically talking of unfavorable condition that's happening to our investment. That is when the outcome is different or deviate from what you expected. Okay, all right. We have two types of risk: systematic risk and unsystematic risk. The other name for systematic risk is market risk. They are risks that happens in the market, and there is nothing you can do to get rid of that risk or minimize that risk. Okay, so we cannot minimize this risk through what? Diversification. All right. Then we have the other one, which is unsystematic risk. This risk affects a particular investment. It affects a particular investment, and it can be minimized through diversification. So if you invested in company A, and the risk and something happened and company A defaults, what's going to happen is going to lose all your investment, right? But then if you are diversified by investing in asset B, asset C, and asset D, then you wouldn't have lost all your investment. You have lost only the portion that you give what A. The rest will be there and you receive it with your returns. Okay. All right. Now, the common way of calculating risk, there are various ways of calculating risk, right? But for now, we are sticking to standard deviation or variance. Standard deviation or variance. We can get variance from that standard. We square standard deviation, we get variance. We root variance, we get standard deviation. Okay. Now let's go to what is return. Return is the amount we get on our investment. Is the amount we get on our investment. So we'll do some simple calculation here. So for instance, if you invest 2,000 in 1 year bond with an interest rate of 25%, with an interest rate of 25%, so that would be what? 25% times what? 2,000, and you are getting what? 500. 25% times 2,000, okay? 0.25 times 2,000, okay? So the same thing, we are getting what? 500 Ghana cedi. All right. So that is it. So this is what? Your return. Right? This is your return. Then you have another way, another example. Also, if you buy shares of 750 and you sell it for 900, you're going to get capital gain. And the capital gain is your return. Okay. So that will be what? Amount received. And if we look at that would be what? Return, because amount received minus amount what? Invested. So you received what? 900 Ghana cedi, because you sold it for what? 900 Ghana cedi. Then you subtract the amount you bought the shares with, which is 750. And at the end of the day, what are we getting? We are getting 150 Ghana cedi. Okay, 150 Ghana cedi. So that is the return you are getting. Capital gain, a return. Now we have rate of return. Rate of return. Rate of return. I would like to face this then. Okay. Let me reduce this so that it will go to a nice shape. Okay. I hope you can see. Rate of return, right? Rate of return. So rate of return, how do we calculate rate of return? That is amount received minus amount invested over amount invested times 100. So amount received rate of return, right? And make it R. We don't have much space, so that is the rate of return. It is calculated here now, and it is calculated of return is equal to amount received minus amount invested all over amount invested. Finance, we don't bring times 100, but we do this. Understanding sake, let me bring times 100. That is why I didn't bring 100, but I end up getting rate. Or maybe at the end of the I so times 100. And from the question, when they sold the shares, when he sold the share, they got what? 900. That is what? The amount received minus the amount invested was 750. Okay. All over amount okay, so that will be equals to times what? 100. So what are we getting? When you subtract 750 from 900, you have what? 150. That will be 150 over 750. I don't want to enter into this question. Over 750 times 100. Okay. Going to divide, what are we getting? 1 divided by 750. That is 0.2. So we have 0.2 times 100. And that will give us 20%. Okay. All right. So I've done it on a pinch, but okay, I think with red, I can do all my calculations. All right, so we are moving forward. Assumption for calculating rates and return. Now, we assume that investors are risk averse, because most investors are risk, they are extreme, and that we have risk levels. All right. Then invested return follow a normal distribution. So that's the two assumptions we have when we are calculating risk and return. Right. Okay. Basis for selecting investment assets. So asset is what you invest in, right? I told you investment vehicle, classes of assets you what you choose from. So asset is what you choose. So asset in this case includes shares, bond, real estate, building, and okay. All right. So first, utility score. When you talk of this, I talk about the satisfaction you get from the particular investment, satisfaction, the wealth you get if it's quantifying money, the wealth of what the investment. So that satisfaction you get from it. So that is it. Then we have mean variance criteria. We use mean to measure what? Return, and we use variance to measure risk. So when they say mean variance criteria, it is when you compare the risk and return of various portfolios or various assets, then you decide which of them best suits your level of risk and the return you expect at the lowest return. So it's up to choose the highest return with the lowest risk. Okay. All right. Then we have mean variance portfolio. This one is more or less interested in risk choosing the asset or the portfolio with minimum risk. As we continue, I think I'm going to learn for portfolio investment management the next section. But portfolio, I don't know whether I taught in the earlier lecture, but portfolio is a collection of investments with the intention to minimize your risk. So you don't put your investment into one asset, but we believe that if the asset collapses, if something happens for your investment spread, we think that the tendency that all different assets or different company collapse at the same time is very low. One collapse, the rest will be there. Then you will not lose all your investment. Okay. Now you're going to do single investment. That's when you talk of single investment. That is where you put all your eggs in one basket. Okay. So that's when you invest in a single asset or a single, right? A single asset. All right. Now, in calculating the return and risk of a single investment, we have two ways. We can use historical data. And when I talk of historical data, so past information. So if you get the past return of a particular fund, you can that you can determine the possible return you get. So if I give information about a return over a period, you can based on it find the average and what you know that give or take, that's what you are going to earn. Okay, all right. So that is historical data. Historical data. I want to put this to pen down. Okay, so we have illustration under historical data on the past performance of a firm. So this is the rate of return of X and Y Limited is for the past 5 years. Sorry, please, I think there's grammatical error. The rate of return of X and Y Limited, XYZ Limited, for the past 5 years was 10%, 20%, 15%, -5%, and 7% for the what 5 years. They're asking you to calculate what the return. Okay. How do we calculate the return? If you remember how we calculated mean, we started learning mean from JHS. JHS, right? Not JHS. We came to SS, we did it. So mean is something. We normally have what sigma S. You have to look for mean. This is a simple for me. Sigma S over N. That's the number of kind. But when it comes to finance, when it comes to finance, we make it sigma R. Make it sigma R. That's why we say we use mean to determine the so sigma R, meaning you are going to add all the returns. When you talk of sigma, is you adding all the returns, then divided by what number of it. Okay. So even though it's here, I'm going to, I think, let me write this one. So let's start. So return. This is the symbol. Will be equals to what? The first information we have, what the first here is what 10%. We are converting it to a decimal. You can still leave in percentile. In this case, you're converting to decimal. So 10% is what 0.1, right? How do you get it? 100, 10 divided by 100. Then you get it. Okay. 0.1 plus, we are summing them. The second one is 20%. 20% will be what? 0. Plus 15% will be what? 0.15. The fourth one is what? -5%. So we bring in minus 0.05. Plus the last one is what? 7%. So plus 0.07. Okay, so we divide all by what? 5, because we have 5 years. Okay, all by 5. So what are we getting? So we add the top. We have what? 0.1, 0.1 plus 0.2 plus 0.15 plus 8 minus 0.05 plus 0.07. Okay, and we have 0.4, 0.47. Okay, 0.1. Okay, all over what? 5. I have to take my time. I didn't take all the space. Let's continue here because I'll be solving the race here. This will be equal to 0. Divided by 0.47 divided by 1. We have 0.094. Because returns are normally quoted, its rate of return are normally quoted in decimal, we multiply it by 100 and we get what? 9.4 percent. Okay, so that is return using historical data, right? Historical data. Okay, now that we have that, we know the return, we can calculate the what? The risk. Risk is just knowing the level of deviation, expected return. So this is expected, and bring expected return. From the expected return. And this one is formula for variation. I think in at JSS that we're doing standard deviation and we root it. Okay, that was let me reframe your mind. So refresh your mind. That is standard deviation. Like that is symbol for standard deviation, and it was equals to sigma into bracket and x minus the mean. All over n minus 1. I said standard deviation, so it was roots. Okay, yeah, so now we are calculating a risk. So it wouldn't, we change all the x and the mean to returns. Okay, so let me just erase this. All right, but we calculate variance. Variance is the square of what? Variance is the square of standard deviation. So if we're to calculate standard deviation of for the return, it would have been sigma r root, right, minus the expected return all over n minus 1. Please, this root affects all. Okay, now to get variance, what? Standard deviation. So when we square both sides, this square will cancel what? This root. So we will now end up with what? Let me use equivalent sign. Okay, that will be equals sigma the individual returns minus the expected. Oh, I don't want to be using the expected return over the number of years n minus 1. Let me go for my eraser and erase something that I don't want this. The equivalent. Okay. So this is that's what's being used here. For space sake, I'm going to erase. For space sake, I'm going to erase. I'm going to erase this, all of this, right? All right. So there's the formula. And when you talk of sigma, I think you're going to add it their value. I think I forgot to bring square. Please forgive me. I forgot to, but there should be square there. If I didn't bring it there. So based on this, we are going to solve the question, right? Okay. So we take the individual return and subtract the expected return from 8, right? Okay, so where can we do this? All right, so we have our variance. I have to write small so that we have our variance is equals to the first return is what? 0. I hope you see this. 0.1 minus the expected return, which is what? 0. Anyways, let me just clean everything. Let me write it on top since it's red so that it'll be clear. It's like I'm squeezing. So we have our variance, the symbol of variance squared. Okay, standard deviation squared is variance. All right, so we have what? The first, okay, let me put in the formula. So it will be R1, R1 minus expected return squared plus R2 minus the expected return squared plus, it's 5, right? R3 minus, and so I'm breaking down the formulas, okay? Squared plus, I have to be careful, R4 minus the expected return plus R5 minus the expected return squared. I think I've got to bring squared here, okay? All over n minus 1. Okay, I hope you can see it. Okay, so if that's the case, we have then variance is equals to R1 is what? 0. Please concentrate on the red ink, not the black one. Minus the return is what? The return is here. 0.094. I'm hoping to go there. Plus the second R is what? 0. Zero point 2 minus 0. This is my point. I don't know why I have issue with this point thing. Point point 0. This thing I think is difficult to read. Let me clean it and get a better place, right? Okay, like I could see that it's difficult to read. That was N. Right. So let's do that. Let's continue here. Okay. The variance is equals to the first return 0.1 minus 0.09 4 bracket close squared, okay, plus R2. R2 is what? 0.2 minus 0.0. That's my point is not clear. That's why I deepen it and I have issues. Okay. 9, 4 squared plus R3. R3 is 0.0 0.0 0.15 minus 0.094 raise the power 2 plus now we are at R4. R4 from the question is negative 0.05 minus, I'll continue down here. Maybe next time go to the same board. Minus 0.094 because the bracket squared plus the final one. We have what? R5. R5 is what? 0.07 minus 0.094. Okay. All over. N is what? 5. 5 minus 1. So we do have calculation. 0.1 minus 0.094. What do we get? We have 0.1 minus 0.094. We get what? 0.006. Bracket close. Okay, the next question, we solve it on a plain sheet. Plus this. That is 0.2 minus 0.094. That is 0.106. Great. Plus this minus this. So that will be 0.15 minus 0.094. Zero point 0.5 this plus, now we're on this negative, so negative 0.05, 0.04, okay, negative 0. Um, negative 0.1 4 plus 0.07 minus 0.09. 0.024. Great, all over. Hey, this is my line there, but I'll maintain it. I will not clean it. Let me, okay. Let me a better line. A better line. Okay. 5 minus 1 will give us what? 4. Okay. Now the next thing is we square this. That is 0.006. This is the power 2. So you're getting a lot of decimals. That will be 0. When you get it, you have to be very careful. Point 0, 0, 4 zeros. Play. Ah, 3, 6 plus. So we are squaring this. That is 0.10 apart. Okay, we are getting 0.1. Sorry, 0 point 0.01123. This. Okay, plus this. Okay, plus the third one is 0.057. 0.05. 0.00311. Three, plus this one, negative. We have negative 0.1 of first. So negative, negative. So there will be no negative. Negative on to become positive. Zero, 2, 0, 7, 7, 3, 6. Okay, plus the final one, which is what? 0 point. Okay, so we got negative. All right, so negative will definitely become positive. 0.02. Okay, 0.02. Okay, we get uh, 0 point 0, 0, 0, 5, 7, 6. So as you can see, this is okay. This, I'm not sure what this is, so let me just calculate it again. 0.1 it is 136. All right, all over what? 4. Going through the process with you. Next time I'll have to probably use but that is 4. Okay, 4. So now we add all these and divide by 4. And I want to go through the process. So equals to, let's add. That is 0.0004 plus 0.011336 plus 0.100136 plus 0.02073 plus 0.023057. Okay, so the answer I think is, my calculator is, I'm not sure, but I think that's the answer that is given. 0.3572 divided by what? 4. Okay. So when we divide it by 4, what are we getting? Okay, I think that answer. So at the end of the day, we got 0. Point 0.008 893. So remember, this is what? Variance, right? Now this variance, we want to get the standard deviation. Standard deviation is equals to root of what? Variance. So that will be equals to root of 0.00893. Okay. So now when we do the root of root of root of root of 0.00893, we get 0.094. Okay, all right. Now standard deviation can be put in percentile form, so you can also write it 9.4. My point is percent. Okay, so that is it. Another thing we can calculate for is covariance. Covariance. That is what we receiving to represent it. That is equals to standard deviation over expected return, the one we calculated out there. Okay, and our standard deviation is what? 0. 0.008. 0.94. That's our standard deviation. All over. Rate of return go up. What is the rate of return? It's what? 0.094. 0.094. Yeah, getting what? 1. Are we okay? So that is for using historical data to calculate risk and return. So we calculate the return, we know the risk. Using variance first, we got the variance, we did the standard deviation, we did the covariance. Okay, so we are good, go. Now we are moving on to the probability. Now probability data. Okay, good to know. Probability data. Normally, if you don't believe in historical data, you want to use probability, then go for the probability. Okay. For the probability, we have this information. I would like to copy this. This information here. In a weak economy, probability 0. Rate of return is 0. Moderate, about 0.5. Rate of return is 0.16. Then strong, in a strong economy is 0.3. The probability was what? 0.20. So with this one, this is how we calculate the return. Okay, so return, by now all of us know the symbol for expected return. With this one, the formula for expected return is just sigma R P, where R is the returns given and P is the price. These are the returns, and this is the profit. And sigma means you are what? Adding them. So let's start. Okay, so to break it down further, for understanding sake, I'll break it down further. So meaning rate of return. According to this, the question you're based on, we have 3. So that will be R1 times what? P1 plus R2 times, oh, I'm not bringing the multiple sign, times P probability plus R3 probability 3. Okay, so that is it. We just insert the values into it. So this will be equals to, I wonder why I don't bring, this is quite simple, so I shall put it. I'm bringing the equals to here, right? Please, so that to be clear. So I said R1 times what? P1. And where is the R1? This is R1. R1 is negative 0.0 8 times the probability is what? The first probability is what? 0.2. I'm hoping to go there plus the R2 is what? 0.10, then probability 2. This one, 0.5. Plus the next one is what? Strong. The rate of return for strong is what? R3 is what? 0.20 times in our bracket 0.5 close our bracket. Okay, so what are we getting? We multiply. The first one is what? 0.08 times 0.2. We are getting 0.0, 0.01 this plus this times this, and that is what? 0.1 times 0.5. Get 0.05. Okay, plus the final one is 0.0 times 0.3. I'm getting 0.0. This. Okay, so what are we getting? We add all. That will be 0.016 plus 0.05 plus 0.06. We are getting, oh, what's that? Okay, 0.016. 0.016 plus 0.05 plus 0.06. You're getting 0.126. Since the result is different from it, I'm going to do, okay? So -0, okay, this is negative. Please, this is negative 0.08 times 0.2. Okay, so that's negative. So let's see, negative 0.016 plus 0.05 plus 0.06. Okay, so we are getting there. All right, so we have this base is supposed to be negative, which is it then? So 0.094, which is equivalent That's 9 points. Because you're getting 9.4, please. It doesn't mean exams. All answers will be 9.4. For exams, I'm bringing different questions. Okay? And I also said that I solve cheap questions and I bring difficult questions. So that is our rate of return. Okay, that's our rate of return. Now we want to calculate the risk. That's our return. We want to calculate the risk. And we know the risk is what? This is the formula for the risk. And sigma R minus expected return squared times what? Probability. Okay, so let's find the ninth place and do. So that will be variance. I thought the symbol of variance is what? I'm hoping it goes there. Equals to, breaking down there. That will be R1 minus expected return times P1. Then plus R2 minus expected return plus R3 minus the expected So let's insert the information. R1. R1 is this. So that is negative 0, 0, 8 minus the expected return, this one, which is 0, 0, 9, 4. Correct. The probability for the first one is what? 0.2. 0.2 plus 1. Everything. Okay, so the second R is 0.10 minus 0.094. Okay. Okay. The probability for the second one is 0.5, so 0.5. We continue here. Okay. So we open our brackets. We attend to the R3 is what? 0 0 point 0 point 20 minus the expected return is 0.094. Correct. The probability for the third one is 0.3. So 0.3. All right, so we are continuing. Now we move. So that was what? Negative 0.08 minus 0.094. We are getting what? Negative 0.174, okay, squared times the probability 0.2 plus, this is 10, please. So that would be what? 0.10 minus 0.094. Okay, that would be 0.006 squared, and the probability is what? Yeah, 0.5. All right, then the last one is what? 0.20 minus 0.094. We are getting 0.106 times 0.3. This should be squared. All right, so want to continue. So we will just multiply them straight away so that we'll finish early. It's like, okay. Let's do it together because time is fast. That is minus 0.174 minus 0.174. And what we get, we multiply it by what? 0.2. And we are getting negative. Because we did all this, so we didn't break it down. 0, it's like they are doing music at the back, so I want us to finish. 0, 0, 5, 5, 8, 4, 8, 2 plus. This one we are doing all of this, okay? So that would be what? 0.006 to the power 2 times 0.5. We are getting 0.0000018. This should be 3, right? Then we multiply this, and there should be square here. So where do you go? Okay. So we come and multiply 0.106 raised to the power 2 times 0.3. 0.3. We get 0.0031827. Okay, so let's add them. That would be what? Negative 0.0058482 plus 0.000. What are the numbers we are trying to write it out to the final answer? 0.03182. We are getting 0. Point 0.02594. Okay, let me make this. Let me run it up. Right. This 0. Two, 5. Sorry, 2, 6, 0. You're getting different answer in the book. But I remember, is it this one? I think there's a mistake somewhere. Okay. So let's say we are supposed to get I definitely made a mistake somewhere. But I'm supposed to get 0.0094 for the variance. Okay, for the variance. So now we want to calculate the standard deviation based on this information. So standard deviation, I said, is what? Standard deviation is equals to root of variance. So that will be root of 0.0094. And that's going to give us the root of 0.0094. Going to give us 0.0 0.097. Okay, and I told you for standard deviation, you can put it in percentile. So if you want to put it in percent, that will be 9.7%. Okay. Then the covariance to be what? I said the covariance is equal to what? Standard deviation over what? Expected return. So that's standard deviation. Standard deviation over the expected return. We know standard deviation is equal to 0.097 over return is what the return is. Okay, let's go up. It's 0.094. 0.094. Okay, so we divide 0.094 divided by 0.7. 0.097 divided by 0.094. So we have what? 1.03. Okay, so I hope you understand how we calculate the return for when we have historical data, the risk, then the return when we are using probability data, and the risk. Okay, when you're adopting probability, right? Okay, all right. So we end here. If we have any question, put it at the comment section. Put it at the comment section. And next week we'll do portfolio management. But now we're going to do we'll be around, so we'll do face to face. All right, thank you. I am ending there.